times 45 times 55. I can't do that in my head. Get about 7.04. Doing okay?
Yeah.
Okay. Now we're going to do x minus mu over sigma, except we're not going to use 70. We need to figure out what we need to use instead of 70. Do we use 69.5 or do we use 70.5? All right. Can you imagine the bell curve in your head with all the little spikes? Okay, imagine 70. We want at least 70. Do we want to include 70 or not include 70? And are we like going to the right or to the left?
At least or right.
Right, at least will be to the right. So do we, if we're including 70, so should we do 69.5 or 70.5? 69.5. And if you can't do that in your head, then you're going to draw a picture, because that's the only way I can think of to do it. So when you're doing x minus mu over sigma, make it 69.5 minus 90 over 7.04. All right, z equals negative 2.91. Grab your A16 chart. I was about to say that I don't know where my A16 chart is, and then I realized I could just look on the book on page A16. Okay, negative 2.91 .0018. So is that the answer? No. Because why? Sorry, I can't hear you. This is so loud out there. Right. This goes to the left, and we're trying to go to the right because we want at least that. So it'd be 1 minus that for the opposite. .9982. I was doing elimination with the 9th graders today, and I did a problem. Ooh, do I have it sitting here? It was so funny. I don't think I have it sitting here. Oh, there it is. So we're doing solving systems of equations with elimination where you're like, oh, we cancel out the 6 and the negative 6, and they cancel out, and you end up finding x and then y, which they also said this was the hardest math that there ever was. Now it's like, disagree, but okay. All right, now, the funny thing is that we did this one, right? 5 and negative 5. And I was like, if you add these together, do they cancel out? And they're like, yeah, 5 and negative 5 cancel out. And I'm like, that's right. Good job. So we canceled them out immediately. This one we had to multiply by negative 1 first because the 6 and the 6 don't cancel out. But I was like, do the 6 and the 6 cancel out? And the whole class like, yes. And I was like, no. And one of the kids like, no, absolutely not. And I was like, that's right. Absolutely not. Like, he went from saying yes to angrily saying no and agreeing. And it really cracked me up for some reason. No. No, absolutely. Everyone. No. All right. Example 4. What % of adults say they never wear a helmet wearing a bicycle?
83.
Whoa. You guys don't know anyone who wears a helmet.
I don't.
You don't know anyone who wears a helmet?
No.
Not a single person.
No.
How many people do you know that ride bicycles?
A lot. Like 2.
2.
Like, a lot. 2.
Okay.
It's a lot.
Please don't answer that way on the AP test when they ask you about sample size. 2. Sounds good. 58% of adults. What do you have? 60. Yes, close. I mean, it's not right, Georgia, but it's close.
I'm not exactly.
That's right. Say they never wear a helmet when riding a bicycle. You randomly select 200 adults. Ask them if they wear a helmet when riding a bicycle. What's the probability that less than 120 adults say they will never wear a helmet when riding a bicycle? I'm going to do this one with you one more time. Here we go. Okay. First thing to check is that you can do this and that it's binomial. So N, P, Q. What's N? 200. P? 0.58. In this case, the success is defined as I never wear a helmet. This one's 32%. What do you have to check to make sure that it works? Times P and N times Q. So 32% of 200. Is it bigger than 5?
It's 42.
Ooh, that's embarrassing. Were you the first one who said something, Nathan?
It's Georgia.
Georgia. Get a prize, Georgia.
It's gotta say something.
Naked.
Mm-mm. Well, someone's got to take a prize for calling me out. I don't care which one of you guys it is.
Nathan's got it.
We're both bowing out.
When I sign this,
Okay. Man, subtraction. Cool.
Crazy.
Nothing like teaching AP Calc and AP Stats and getting nailed with subtraction. All right. 42. Okay, so what do we have to check? P or Q? Q, 42% of 200. Bigger than 5?
Yes.
Yeah, I feel like it is. N times Q is bigger than 5. Yes, it is. All right. Now we've got to do the mean and the standard deviation. You guys get the same thing? 116 and 6.98. Anybody? Noah,
Yeah.
did you get these?
I got 6.97, but I didn't round.
Okay. All right. Now we're going to do x minus mu over sigma, but we have to change x. All right. This is the part where you actually have to use your brain. Less than 120. Do we include the 120? Less than 120. We're not including 120. It's less than that. So 119.5. So 119.5 minus 116 over 6.98. I got a z-score of 0.5. Then you got to look it up on A16. .6915. And I don't have to subtract that because I'm going